and that's what's traveling in our conductor. And these free electrons, they move around in our electric circuit. So what's the problem associated with that? Actually, our current direction is wrong. Yeah? So the electrons, if you think about the battery, on the right-hand side, we got a higher number of electrons than on the positive side. That means the electron, they travel in exactly the reverse direction. So the electron movement or the current movement is actually from the negative pole, and it travels to the load, and then it travels back in this direction. Yeah? So the physical direction of current flow is actually from the negative pole to the positive pole. Yeah? But this was discovered around 1910, 1920, and all the textbooks were already in print, so that the currents went from plus to minus, so the current direction hasn't been changed. So what we are talking about is the technical direction of current flow. The red one is the technical direction. So if you are designing an electronic circuit, or if you're calculating an electronic circuit, you don't have to care about electron movement. All the time we are calculating only with the technical direction of current flow. So if you see a diode, the diode is always referenced to the technical direction of current flow. But if it goes down to semiconductor mechanics, then we have to account for that there is no red technical current flow, there is the physics. And if in physics, the electrons move from minus to plus. Yeah? So to understand semiconductors, you have to think about the physical aspects of current flow. Yeah?
Calculation, we use physical.
In calculation, we use the technical direction. Yeah? But actually, for the calculation, it doesn't matter at all.
The direction of the current.
Yeah. So that's only numbers. So now we have some idea what is going on here. And now my next question is, how fast do they move the electrons? Do you have any idea? So everyone has actually, maybe it's a battery, 12 volt or whatever. There you got a bulb. You connect this and the bulb lights up. So how fast do the electrons move?
As fast as we connect it.
Maybe you put in here a switch, an element to turn the current on and off. So you see, to turn off the current is quite easy.
So open the circuit.
You just cut the line, yeah? And the current movement stops immediately. Yeah? So, and if we close the switch, the circuit recovers, the electron movement goes on. And how fast do the electrons move? Any idea? Guesses?
Yes, the speed of
Light.
Speed of light? So it's the...
Because the maximum speed is the speed of light, I think.
That's actually the maximum speed. You know from physics, so matter. But matter is not allowed to move with speed of light.
Mm-hmm.
So it must be a little bit down here. There is no...
99.99% from the speed of the light.
Sorry?
99.99% for the speed of the
So
light.
let's first guess, yeah, let's stick to that. 99% of the speed of light.
Yeah.
How fast is the light?
That's
300,000 kilometers per second.
So, meters per second. So it's actually 300,000 kilometers per second. Any other idea or any other guess? How fast are the electrons? So the speed of light is not correct. Any other idea? Are there any other velocities?
the speed of sound.
Speed of sound, yeah, maybe.
But that's slow speed.
Slow speed. So let's see OS. How fast is the sound?
No, I don't know.
It's actually slower than light. Huh?
Yeah,
Yeah.
yeah.
So
Okay.
it's 344 meters per second. But it's also not correct. Is any other idea?
Below these two. Below these two.
Between these two? Or below the speed of sound?
Below or maybe between.
It's between both of them, but
Between, yeah.
I think yeah, because it cannot be less than the speed of the sound. I think.
So what I want you here is just to think about the thing. It doesn't care if your answer is correct or wrong. The main thing is to start to thinking about that. Yeah? So it's way below the speed of sound. It's some centimeters per second. Yeah? So the movement of the electrons within the wire, it's some centimeters per second. Yeah? That's actually, this might be a problem. Yeah? So if